Adding a control module to the data line is a valid method to connect a fire alarm system to an Ansul hood suppression system. The control module should connect to the Ansul system at the following points. Firstly, fire alarm contact input. The module should monitor a normally open contact input on the Ansul system that indicates the activation of the fire alarm. Secondly, suppression system activation output. The module should provide a normally open relay contact output that activates the Ansul suppression system when the fire alarm contacts close. Thirdly, data line connection. The control module should connect to the data line of the fire alarm system. This line typically uses a 2-wire AS-485 or a similar protocol. The module should be programmed with the correct address and data format for the fire alarm system. Ensure that the control module is compatible with both the fire alarm system and the Ansul hood system. Verify that the data line is properly installed and terminated. Program the control module with the appropriate settings. Test the system thoroughly to ensure proper operation. Code requirements may vary, so consult with local authorities for specific requirements. The control module should be installed in a secure and accessible location. The system should be maintained and tested regularly to ensure reliability. Connecting a fire alarm system to an Ansul hood system requires careful planning and execution to ensure the safety of occupants and the proper operation of the fire suppression equipment. Firstly, understanding the fundamental principles of both systems is crucial. The fire alarm system is designed to detect fires and alert occupants, while the Ansul hood system is specifically designed to suppress fires in commercial cooking environments. The integration of these two systems ensures that when a fire is detected, the Ansul system is automatically activated to extinguish the flames. Secondly, the control module acts as an intermediary device that facilitates communication between the fire alarm system and the Ansul system. This module is typically connected to the data line of the fire alarm system, which uses a communication protocol such as AS-485. The module must be programmed with the correct address and data format to ensure seamless communication with the fire alarm control panel. Thirdly, the connection points to the Ansul system are critical for proper operation. The control module should monitor a normally open contact input on the Ansul system that indicates the activation of the fire alarm. When the fire alarm is triggered, this contact closes, signaling the control module to activate the Ansul system. Simultaneously, the control module provides a normally open relay contact output that activates the Ansul suppression system when the fire alarm contacts close. Fourthly, the implementation notes are essential for a successful installation. It is imperative to ensure that the control module is compatible with both the fire alarm system and the Ansul hood system. Compatibility ensures that the module can interpret the signals from the fire alarm system and send the correct commands to the Ansul system. Additionally, verifying that the data line is properly installed and terminated is crucial for reliable communication. Poorly installed or terminated data lines can lead to communication errors and system malfunction. Fifthly, programming the control module with the appropriate settings is another critical step. The module must be programmed with the correct address, data format, and other parameters to match the specific requirements of the fire alarm system and the Ansul system. Incorrect settings can result in the system failing to operate as intended. Sixthly, testing the system thoroughly is essential to ensure proper operation. After the installation and programming are complete, the system should be tested under various scenarios to verify that it responds correctly to fire alarms and other emergencies. Testing should include simulating fire conditions, activating the fire alarm system, and confirming that the Ansul system is activated promptly. Seventhly, additional considerations include code requirements, location, and maintenance. Code requirements may vary depending on the jurisdiction, so it is important to consult with local authorities to ensure compliance with all applicable regulations. The control module should be installed in a secure and accessible location to protect it from damage and unauthorized access. The system should be maintained and tested regularly to ensure reliability. Regular maintenance includes inspecting the control module, verifying the data line connections, and testing the system's response to fire alarms. Eighthly, understanding the specific components involved in the connection is vital. The fire alarm system typically consists of smoke detectors, heat detectors, pulse stations, and a control panel. The Ansul HUD system includes nozzles, a suppression agent, and a fusible link that triggers the system when exposed to high temperatures. The control module acts as the bridge between these two systems, enabling them to work together seamlessly. Ninthly, the data line connection requires careful attention to detail. The data line is typically a two-wire cable that carries data signals between the fire alarm control panel and the control module. The cable should be shielded to protect it from electromagnetic interference, and it should be properly terminated to ensure a reliable connection. The control module should be programmed with the correct baud rate, parity, and other communication parameters to match the fire alarm system. Tenthly, the fire alarm contact input and the suppression system activation output are critical interfaces. The fire alarm contact input allows the control module to monitor the status of the fire alarm system. When the fire alarm is activated, this input changes state, signaling the control module to take action. The suppression system activation output allows the control module to activate the Ansul system. When the control module receives a signal from the fire alarm system, it closes this output, which triggers the Ansul system to release the suppression agent. 11thly, ensuring proper grounding is essential for the safe and reliable operation of the system. The control module should be properly grounded to prevent electrical noise and interference from affecting its performance. The grounding conductor should be connected to a dedicated ground point, and it should be sized appropriately to handle the expected fault current. 12thly, documenting the installation is important for future maintenance and troubleshooting. A detailed record of the installation should be kept, including wiring diagrams, programming settings, and test results. This documentation will be invaluable for technicians who need to service or repair the system in the future. 13thly, providing training to personnel is crucial for ensuring that they understand how the system works and what to do in the event of a fire. Training should include instructions on how to activate the fire alarm system, how to verify that the Ansul system has been activated, and how to evacuate the building safely. 14thly, conducting regular inspections is essential for identifying potential problems before they become serious. Inspections should include checking the control module, verifying the data line connections, testing the system's response to fire alarms, and inspecting the Ansul system for any signs of damage or wear. 15thly, keeping the system up to date with the latest software and firmware is important for ensuring that it operates at peak performance. Manufacturers often release updates to address bugs, improve performance, and add new features. These updates should be installed promptly to keep the system running smoothly. 16thly, considering the environmental conditions is crucial for ensuring the longevity of the system. The control module should be installed in a location that is protected from moisture, dust, and extreme temperatures. The data line should be routed in a way that minimizes exposure to physical damage. 17thly, planning for redundancy can enhance the reliability of the system. Redundancy involves installing backup components that can take over in the event of a failure. For example, a backup control module can be installed to ensure that the Ansul system is activated even if the primary control module fails. 18thly, coordinating with other building systems can improve the overall fire safety of the building. A fire alarm system can be integrated with other systems such as the building's HVAC system and elevator system to automatically shut down these systems in the event of a fire. 19thly, understanding the limitations of the system is important for managing expectations. The Ansul HUD system is designed to suppress fires in commercial cooking environments, but it may not be effective against all types of fires. The fire alarm system is designed to detect fires, but it may not be able to detect fires that are hidden or smoldering. 20thly, consulting with experienced professionals is always recommended. Connecting a fire alarm system to an Ansul HUD system is a complex task that requires specialized knowledge and expertise. Consulting with experienced fire alarm technicians and Ansul system technicians can help ensure that the system is installed correctly and that it operates safely and reliably. Firstly, it is important to understand the relevant standards and codes that govern the installation and operation of fire alarm and Ansul systems. In the United States, the National Fire Protection Association, or NFPA, develops and publishes codes and standards related to fire safety. NFPA 72 is the National Fire Alarm and Signaling Code, which provides requirements for the installation, testing, and maintenance of fire alarm systems. NFPA 96 is the standard for ventilation control and fire protection of commercial cooking operations, which provides requirements for the design, installation, and maintenance of Ansul hood systems. Secondly, the control module's power supply should be reliable and properly sized. The control module requires a stable power supply to operate correctly. The power supply should be sized to provide sufficient current to the control module and any connected devices. It is also important to ensure that the power supply is protected from overloads and short circuits. Thirdly, the wiring connections should be neat, organized, and well labeled. Proper wiring practices are essential for ensuring the reliability of the system. The wiring connections should be neat, organized, and well labeled to facilitate troubleshooting and maintenance. All wiring should be performed in accordance with applicable electrical codes. Fourthly, the control module should be mounted in a suitable enclosure. The enclosure should protect the control module from physical damage, moisture, and dust. It should also be large enough to accommodate the control module and any associated wiring. The enclosure should be mounted in a location that is accessible for maintenance. Fifthly, the system should be tested periodically to verify its functionality. Periodic testing is essential for ensuring that the system continues to operate correctly over time. The testing should include activating the fire alarm system, verifying that the Ansul system is activated, and checking all wiring connections and components. The results of the testing should be documented and kept on file. 26thly, the system should be inspected regularly for any signs of damage or wear. Regular inspections can help identify potential problems before they become serious. The inspection should include checking the control module, wiring connections, and Ansul system components for any signs of damage or wear. Any damaged or worn components should be replaced promptly. 27thly, it is important to keep a record of all maintenance and repairs performed on the system. A detailed record of all maintenance and repairs performed on the system can be invaluable for troubleshooting and preventing future problems. The record should include the date of the maintenance or repair, a description of the work performed, and the name of the technician who performed the work. 28thly, it is crucial to have a plan in place for dealing with false alarms. False alarms can be disruptive and costly, so it is important to have a plan in place for dealing with them. The plan should include procedures for investigating the cause of the false alarm and taking steps to prevent future false alarms. 29thly, the system should be designed to minimize the risk of accidental activation. Accidental activation of the Ansul system can cause significant damage and disruption, so it is important to design the system to minimize the risk of accidental activation. This can be achieved by using tamper-resistant components and implementing procedures to prevent accidental activation. 30thly, the system should be designed to be easy to use and understand. A system that is easy to use and understand is more likely to be used correctly in the event of a fire. The system should have clear and concise instructions, and it should be designed to be intuitive to operate. In summary, connecting a fire alarm system to an Ansul hood system requires careful planning, execution, and ongoing maintenance to ensure the safety of occupants and the proper operation of the fire suppression equipment. By following these guidelines and consulting with experienced professionals, you can help ensure that your system is installed correctly and that it operates safely and reliably.